Well, looking at this problem where we're asked to determine how many seeds would it take to kill the average American, we're going to see a lot of data. So when you see a problem, a word problem that has a lot of data, you're probably looking at a conversion problem that involves that fence post calculation, because you're going to have a lot of conversion factors, or what we call our boxcars, that are in the middle. And we need to find a beginning point for this problem, and we need to find what we want to end with. So let's do those two ends first, and then we'll kind of build the middle. It says how many seeds would it take. So we're looking for some number of X seeds, some amount of seeds are going to be needed to kill an average American male. And this value kind of stands alone. It's not a part of a ratio. So it's needing to kill an average male that is that big, that much weight, 88.32 kilograms. I'm going to take my Sharpie and just kind of highlight some of the things that are probably boxcars, and maybe even box them in. So if it says 700 milligrams or 700 milligrams of cyanide per kilogram of seeds, that's a dead giveaway that is going to be one of those conversions that's in the middle between the starting point, 88.32 kilograms, and what we want as a final answer. We see another one, of course, here, the lethal dose of cyanide for a specimen, organism, is 1.5 milligrams per kilogram of that organism taking it in. They usually study, of course, rats or whatever for this to determine LD50s. And then the last one, it says each seed weighs about 0.70 grams. So we're going to box that in because it's saying we can tie the weight of each seed to 0.700 grams. So let's pull this together down here, and by just looking at what do we need first? Well, if we're doing fence post calculation, conversion, train, or whatever, we need to make sure the units always cancel. And again, we're not doing the changing the ratio problem where you have, and I'll just kind of highlight it up here maybe, we're not doing something A over B is equal to C over D and doing cross multiplication. There are some problems where you can do that. This ain't one of them. So we're going to look for something that has kilograms of that organism. And it's really right here. We can see this is 1.50 milligrams of the cyanide, the poison, for every 1 kilogram of the specimen that's killing. So we have these kilograms that are going to be able to cancel. And now we're talking cyanide. Let's see if there's anything that talks about the cyanide in milligram terms that we could bring in right here. And we do. We see 700 milligrams of cyanide. Now this is a big number on the top, milligrams of cyanide for every 1 kilogram of seed. So it takes a lot of seed to have just a little bit of cyanide, which is hopefully the case, because I like to eat, I guess, almonds and other things that have cyanide in it. So now we notice, hey, we might need to change this, because our last conversion, we've used this one now, we've used this one. It says each seed weighs about 0.700 grams. Well, I don't have my term right, and I don't have it in grams, but I can get it there. I can say 1 kilogram of seed can also be written as 1,000 grams of seed. And our last conversion is taking us from the weight of the seed. Each seed weighs about 0.700 grams. That's the weight of 1 seed. So we're ready now to cancel our units and see if we have what we need as a math to find our value of X. So kilograms cancels with kilograms. Milligrams of cyanide with milligrams of cyanide. Our kilogram of seed with kilogram of seed. Our gram of seed with 0.70 grams of that seed is equal to 1 seed. So it's the weight, I should say, 1,000 grams of that seed is needed. It said, or that's what we're needing, a lot of that seed, but we're taking that 1,000 grams and we're saying each one is weighted as 0.700 grams. So this also cancels grams with grams. And this is a number of, maybe that's the best way to say it. This is the weight of, and we're in the numerator we have number of. So we know that the one seed weighs this much, and we're needing to divide by the weight so we can find the number of seeds. So this is good. All the units cancel, and we're looking at just the number of seeds as our last unit that's left. So if we do the math, we're going to take that 88.32 times it by the 1.50, and I usually just work across the top. 1.50 times the 1,000 equals. So I've multiplied it across the top and hit equals, and we have 132,480. But now I'm going to divide by 700, hit equals. Then I'm going to divide by 0.70 and hit equals. So it comes out to 270.4 seeds. And as far as the number of sig figs, we'll stay with 4. We had our number of sig figs for this American male's weight as 4. We'll just stay with 4. That's how we do conversion problems, using them along the way. That hardest type of conversion problem, we called it dimensional analysis. We called it conversion train. You're finding your boxcars, and again, make sure, even if you're not sure what to do to make your equation, at least tag things. This is a ratio. I'm going to tag it as such, or even write it to the side as a ratio. And then kind of know what you want to get to and put that over on the other side of the equal sign. And most importantly, find what your starting point is, because then you can start to know how you're going to have to cancel your units. It's always top to bottom, and you move along your train. Thanks.